you back. And today we'll talk about some tips and tricks in SolidCAM and Solidworks also, and also what's related to what's new in SolidCAM 2014. This is the version that I present today. And so the issues will be I will present those issues and depending what we are talking about. So I'm starting with some tips about using fixtures and the building fixtures in SolidWorks. So in SolidCAM we need always to define the fixtures, to define the setup, and some users complain that, oh, it's a lot of work. If you start using all the advantage that SolidWorks can give you, so this work and this setup can be very easy and very fast. In this way we can use the power of SolidWorks, and also we can see in SolidCAM the good machine simulation and the good simulation of the part and the good setup, and we can have all those advantages, but in a short time. So let's start with a simple example of building fixtures in SolidWorks. You all know about those fixtures that you can buy. They are ready to buy fixtures, but you also can machine them by yourself. Yes, but there are different dimensions for different chucks diameters. So I built here the fixture for a chuck 10-inch that I have on machine I present to you today, and I use them every time. I save them in a folder, special folder, the fixtures, and I use them every time. So only it's not a lot of work, only 3 features here. I have a boss extrude and 2 cuts for drills, change radial position. We all know that those fixtures can be moved on the spindle, and we have some slots on a distance. The standard distance is 1.5 millimeters, so we can move them on a different diameter with this feature, move and copy bodies. So I define here 9 millimeters movement. That's mean 6 slots. I will move up, but the fixture is defined as in the close position. So from this position I can move externally each jaw. Unsuppress, and I have one. After this I will copy twice 120 degrees. So this is a ready fixture that I can buy and I have in my factory, and now I will import in my assembly discard. Show. Now I have this fixture, but now I want to cut this fixture and to make some turning operation and to have this fixture to fit my stock. All those operations, the cut revolve that I do, I will do them here in assembly, not in the part. In the part I have only the features to build the jaw, but here in SolidWorks we have assembly, and we have here the functions to cut and to move and mirror and rotate and a lot of features that we can use. So cut revolve I will do here in assembly. In this way, the original part will remain unchanged. So I can use it again and again on different parts. But for this specific part, in this assembly of my part, he will be after the cutting in this way. Let's suppress the first one and suppress the second one. This is the original picture. I will cut now. We make it shorter. Yeah, the first cut is revolve, depend on the stock. The second cut is to make it shorter, and third cut to give some angle to have place here to work with the tools. That's all. 3 features, and I have a ready fixture. Now, when I import this fixture in a SolidWorks assembly, I will use mates. Yes, the fixture will be concentric to my part, and I put it on the distance. The plane of the fixture, that means this plane will be connected to the spindle. This plane is on a specific distance from coordinate system of the part, from this face. I have 120 millimeters, for example. And one of the jaws will be parallel to ZX plane of the part. The same for sub-spindle fixture. I bring the fixture unchanged. Let's suppress. This is the fixture. I position the fixture, and now I will cut the fixture in assembly to fit my part. Unsuppress. The first cut is to make it shorter. Unsuppress. This is a sketch, and now to cut at this specific angle. Here I have another revolve cut, because when I'm going to work here with the grooving tool, my shank will touch the fixture. That means I will have a collision. I see this collision later in machine simulation, and I just add a cut revolve to the fixture to avoid the collision. So the simple way to define the fixture is to have a ready fixture built and import it in the SolidWorks assembly, make a few cuts, and you have the exact fixture that you need on the machine. Also, you can make now operations and turning operations to machine the fixture. You can program the operations and to cut the fixtures on the machine. Now, after we design the fixture, maybe I want to save this, to use this fixture in the next part. So let's save the main spindle fixture. Hide. Oh my God. I have some problems with my drivers. In the last day, I do some major update from Microsoft, and if my computer will go and freeze, just wait for me 3 minutes, I restart and come back. But it's happened to me in the last days or a lot of times. Okay, I will hide the stock, and I will hide the design model. Now this assembly, save as, and I will save it not as an assembly, I will save it as a part. All components, and go to, I have here the folder where I save the fixtures. Here is the original. Now I save the main spindle, the original, and I will save now the last version. Replace. So I always have also the last version of fixture. If I'm going to open last version, I have the last version, and I can use it in the next part. So this is the way that I recommend to work. Show the part, show the stock, and show subspindle feature. Another advantage is when I need to do some change, so I will use the mates that I define here, distance. For example, I want to pull out the part to be on a bigger distance from the main spindle. Let's go and increase the distance, rebuild. Automatically my fixture is changed automatically, and I will synchronize in SolidCAM, and the setup and the fixture will be updated. Check synchronization and synchronize, and will be updated. The same for subspindle. I have distance 150, rebuild, and we have a new fixture with a very fast change. Now this distance 120 for the distance of coordinate system from the main spindle, I will use in setup. Distance of map 1 position 1 from submachine number 1, upper turret with main spindle, Z120. Now you can see that the fixture is positioned correct on the spindle. Now if I put a different value here, yes, we can see it's not fit. The fixture is not positioned okay on the spindle. So, as I say, when we talk about options, I will tell you what's new. So this is a new option that you have in SolidCAM settings to show you the machine view in a SolidWorks environment. That means if you have a machine simulation, you have STLs, and SolidCAM can show you today from STLs from machine simulation, 3D models, here in the setup. And it helps you to have an easier way to show if your dimensions are correct or wrong. Now let's see also for subspindle. You can see I see here the subspindle. All those are STL files from machine simulation folder. I can see here also the main spindle, upper turret. So my setup here is correct. Okay, let's continue. This was the first issue that I wanted to talk about, building fixture and in a very fast way, and save them and change them very fast. Now I want to talk with you about using MCO machine control operation cycles, MCO cycles. We built the support guys, whoever will define for you the machine and will rotate the post processor, have the option to define cycles inside the VMID, inside the machine definition file, ready cycles, parametric cycles, where we can define which parameter the user can change and to have a very fast cycle for a transfer from main spindle to back spindle, for using the back spindle as a tailstock, for any usage. We can use it in we have many requests from the customer. Build for me a cycle for this or for this. And many times the machine reseller, the support guide, he will build for you a built-in cycle inside the controller. So you will call it, for example, with a G65P and the program number. Yes, you call a cycle, a built-in cycle in the controller with some parameters. This is what we can do to support, this cycle will support your ready cycle in the controller. Now, how we use this? All this information is to view only for you, for the user. The technical, the support guy will define for you the cycle with all the parameters, and you just need to add a machine control operation and select the ready defined cycle from the list. So I define here a few: a milling transfer, a turning transfer. Milling transfer, that's mean when C-axis, both spindles are working with C-axis connected. It's a milling mode. And turning transfer when the spindle is spinning. Both spindles from main and sub-spindle, they are spinning and are synchronized. Now milling and turning transfer with pushing check. The advanced machines today, they have an option like the Renishaw, the pushing check. They will check the force when you come with the sub-spindle and want to catch the part. The axis movement is controlled, and when the jaws touch the part, the axis movement is stopped. So this function is called in Morisaki, for example, is pushing check, is G38, G code on the machine cycle, and I use this cycle here. So I will select the turning transfer. This is what the user see. Parameters. Only this. All the rest, all the logic of the transfer is inside. The user don't see it. And because it must be simple. With changing only a few parameters, you will have a ready transfer process. What I want to give to, what options I want to give to the user here. Turret retract. Where is going the upper turret to a safe position? In Z-axis. Minus 780 millimeters. B angle for turret and Y. Now, because it's a turning transfer cycle, spin direction, you can define clockwise or counterclockwise, spin value. And now, 3 points. I will bring the sub-spindle with rapid movement to a clearance, let's say 10 millimeters before the part. Go to the second point with feed, let's say 1,500, that depends on you, and from the second point to the third point I will activate the pushing check function and go with a small feed, 30 millimeters per minute, for example. The last parameter is refraction stroke. In the moment that the sub-spindle will touch the part, is going back, have a retraction for 0.01, or it's defined by you, depend on you. So let's say I want to define first point where I'm going with the sub-spindle. I have here the sub-spindle. I will put it ZX plane, and with the mouse wheel I'm going to bring sub-spindle to the place. Let's put the sub-spindle jaws, let's change to transparency. Now, here is my part. After the turning operations, of course. On this position, I already touched the part. Now I want to go back 10 millimeters. So in this position I come with rapid. Second position, again, let's say that we'll start from the previous position, 1, 3, and we'll go. Now the face of the part in the final position will touch the jaw. This face is like the stopper. But here I will define not the final position and only the second. Here I will touch the part, I will go back 3.5 millimeters. To this point I will go with 500 millimeters per minute and go to the last point. With pushing check function activated. Let's make the zoom, and I have with Control and Shift 0.1 movement. I'm in the correct place. Now, 3 points that the user need to define to have the movement as a transfer cycle ready. Save, simulate. This is a Morris AKNTX 2000 machine with 1 upper turret B-axis type and 2 spindles. I will hide the stock. First movement is the upper turret will go to a safety position, X up, Y retraction to minus 125, and Z minus 780 as we define in the cycle. And those values are parametric values that the user can change the safety position, the retraction position in every cycle. The next movement, sub-spindle go to the clearance position, go to the second position. You can see the part is not touching this face of the jaw. That means it's not in the final position. And last position. Here we close the jaws, we open the main spindle jaws, and retraction. We have simulated transfer cycle. Now, that's not all. We need also G-code to send to machine. The G-code will appear in this way. We have a turning transfer pushing check operation with retraction and of turret in X, retraction of subspindle to reference, go to Y on a parametric position that the user defined, B-axis also the user can change, and Z. Now subspindle is going to enter in a turning mode, that means the axis disconnected, open the jaws, main spindle turning mode, activated the spin rotation, activate synchronization between the spindles. Now also the subspindle is rotating. Go with subspindle with rapid to the first point, with feed to the second point, and activate now the function of pushing check. Close the jaws with a small delay, 1 second delay. Close the jaws on the subspindle, open on the main spindle, again delay, retract, subspindle to reference position, stop the rotation, and cancel the synchronization. And you have also an optional stop. Now, all this, if you have, as I said before, already a subroutine in the controller, a ready programming controller, we can instead to print all this in the G-code, we can print your subroutine call, G65 program number, whatever number that you have there, and the parameters of position, of whatever these cycles contain. we can print in the cycle the parameters. That's mean two options: use a ready cycle or use SolidCAM output. Both are okay to use. Also, if we define a correct setup, we talk about setup first. If we define a correct setup, because we know when we define the machine, we know where is the reference point of all axes, we know where is the main spindle, where is the back spindle. If I say now, hey, my part with coordinate system is 120 millimeters from the main spindle, I know exactly where will be the coordinate system on the machine, where G54 for Mach 1, what are the values for this home position. That means you even don't need to define the home on the machine. The program will do this for you. With commands G10L2, I will input the values in the machine work offset table. This command depend on the controller. Also Heidenhain, Siemens, and any other controller, they have something similar in different format. But we always can send the home to the machine. Okay, next subject. We will talk now about work area. The work area is an option in SolidCAM, in rough technology. But not many users know this option and they don't use it, but it's very useful. We, in a rough turning, we always use the stock. That means our toolpaths depend on stock. We know the stock, and I have the geometry, and I know, oh, all this material here must be removed. So I will build, SolidCAM will build the toolpaths for this. But there are some cases when you don't want to use the updated stock, the stock that you define. Maybe your material come with a bigger diameter, a large diameter, or a longer stock you have. And this difference will affect only the rough operation. So you don't want to go and define stock again. Yes, it was a mistake and somebody bring you stock not on correct dimensions. But the next time you want to save the part with correct dimensions, not the changed part. So what can I do? I will use work area and define specific for this job a different stock. Work area, and here I define let's replace the chain. That's the second example that I want to show you. Work area, constant Z. I define a chain and say, hey, this is not my stock now. For this operation, I have a bigger stock now, different dimensions. And this will affect only this operation and not the entire part. Save and calculate. And I have a longer toolpath and also additional passes here because I have a different stock. Now, again, what's new in SolidCAM 2014? Tools, STL holders. We can see them also in HostCAD simulation and Solid Verify. Solid verification in HostCAD. That's new. Fixtures and also holders. Now, go back to work area, and to understand how it's working, I will replace the chain with this example. The chain of work area, it's not a replacement of the stock, it's additional to the stock. That means I will add to the defined stock of this part, I will add some differences. I have here a small additional material that I want to remove, or I have, depend on the chain that you define. This work area is additional to updated stock, not instead. This is very important to know. So save and calculate, and now let's see the toolpaths. We have the regular toolpaths, but we have additional passes here because I add here a work area chain. So this chain, this option is very useful in some cases, and you need to know when and how to use it. Now, related to changes to what's new also, in turning operations link, we have a change here. We, from 2013 to 2014, we need to add lead in, lead out on finish passes. That means we want to make it standard as in the milling. In milling, you don't add lead in or lead out, you don't have it. Also in turning, you don't add any lead in, we will not add automatically. We will add something automatically, but a very small extension, just not to crash on the part. There's not to cut to have a collision. So in the rough operation, we add for rough passes, we add safety distance. That means the tool will start safety distance 2 millimeters before the stock. But on finish, you can see here, this is the last pass, the finish. We have only the radius of the insert plus 0.2 because this is the pre-track distance value. So we have 0.2 plus tool radius. It's a minimum distance extension that we add, just not to have a collision on part. Let's simulate. I don't want solid. Let's remove work area, general. I don't have work area. Save and calculate. Okay, you see in the rough passes we have safety distance added. Go, go, go. Let's zoom. And for finish, we have only a small extension of 0.2. That's the retract. If you change it, you have more. And now you need to add lead in. I will add 2 millimeters a tangent extension, so I will have a 2 millimeters extension. That's the change between 2013 to 2014. On the finish, you need to add by yourself the extension lead in and lead out. And let's go to the next part. SolidCAM and turning demo. One of the new options that we have in 2014 it's option to use in a turn drill to select a milling tool. So before that you can select only drills. Today I can select any mill, ball mill, bull mill, and any type of milling tool. Also in drilling. That's new. And we have in the previous version the operation turning eye machining, but it was inside the turning operation in technology in RAF. We had the option here eye machining, turning eye machining, yes, in the RAF. Today we take this option and put it on our menu here. Add a turning operation, eye machining turning. So this is new also. Here in eye machining turning we can use a grooving tool with a rounded insert. Eye machining needs a rounded insert to work. For now, maybe in the future we can calculate a toolpath also with a square shape insert, but for now is working only with a rounded tool. What else we have here? Technology is the same as in turning, but the step down, it's like the same as in eye machining. We have step down that you can define minimum and maximum step down, or you can work with cutting, minimum and maximum cutting angle. Also we have one way or zigzag and offset. Also this is new in 2014. Before that we calculate depend on tool mounting that we select here. We do some calculations and we output a negative X. But today it was very difficult to calculate for a grooving tool, because a grooving tool can work negative and positive as on face, for example. There's no problem. So how to do this automatically? So today it's an option in technology. If you want a negative toolpath, you just select negative X and your toolpath will be negative. Semi-finish is the same, nothing new here. Links and approach and retract point. We talk about approach and retract point in previous webinars, but I always want you to remember this is very useful in programming turning operations. Yes. So for example, in drill, I prefer automatically a drill operation will select from right safety corner. That means the drill will come here in the right safety corner, maybe 1-2 millimeters, depend on safety that you have, and go down very close to the part and start the drill. So I don't like it, so I will use all those options that I have here. X first. First go to X from this diameter to 10 millimeters and make the drill. Retract Z axis first, retract to 10 millimeters and go up. So my toolpath will be like this. I have the option to have a more safe toolpath if I want. Go to 10 millimeters, come here with rapid and start drilling. Go back to 10 millimeters and retract. That's a very useful options that you have, and you can play with them every time. Another example of using approach and retract point is when I will show you now. I have an example here. I will come with subspindle, catch the part, and I want to machine this groove here. Yes, so I have the part catched by main and subspindle both together. I don't have many places here. If my tool comes to the right safety position, I will have a collision between the tool and spindle. So here, for this operation, also I use iMachining for the grooving. This approach and retract point is my only option to define a good tool path. Only in X, so that means from the tool change position, come, or from the previous operation, come here. From this point, you will go to start of the tool path. Process, machine the part, and retract only X to this diameter. I can increase the diameter how much I need. And from here go to maybe to a change tool or to next operation. But don't go to right safety corner because you will collision with my subspindle jaws. Grooving finish, and okay, so let's start simulating this. Oops. המחשב שלי קפא, אני חייב לעשות ריסטארט, תגידי להם 2 minutes, I'm back.
Sorry everyone, Florine is having a bit of a problem with his computer, so this is also a good time for questions if you have any. And I would also like to remind you that at the end of this webinar we will send you the link to the recording, so if there's anything that you would like to review again, then you can always watch the recording. And of course on our website you can find the rest of the recordings from all our previous webinars by topics, and also of this series of the What's New in SolidCAM 2014. So this is always available for you. How are we doing, Florine? Okay, so we'll wait a couple of minutes.
Turning iMachining. It's a very good toolpath to remove material. The same as in milling. Now retract. We have an MCO, machine control. Retract the upper turret because I want to come with subspindle and catch the part. Now change the tool and you see this is a very small place to move. So with a correct setup, with correct fixtures, correct design, you can have a very precise program, a very good program, and you can send it to machine without fear. Now I will finish the groove, the grooving finish operation, down only technology. Retract, take the part to subspindle reference, continue to work on the opposite side. Drill, face, same, with the same tools, with different spindle orientation. Yes. Also, again, eye machining, turning eye machining here. And a small slot here after, a small release after, and threading. Retract, use MCO for turret retraction, and that's all. So that means today, with a correct setup, correct fixtures, you have a very good program, ready to send to the machine, program and simulated, and a very safe G-code. Let's show G-code. It's a G-code for Moriseiki, this type NTX 2000 with Fanuc 35i controller. I will send a tool list, homes, as we talked about this before, and tool change, operation, another tool change, operation, and that is the program that we send. That's all that I wanted to talk with you today. So enjoy the new version, the new SolidCAM 2014 version. And we wait for feedbacks from you.
Okay, Florin, thank you. We have one question about automatic hole recognition for surfaces. He's asking if we have it in the turning model.
Hole recognition is working in a mill turn machine. And our webinar today is for turning. If you have a mill turn machine defined, yes, any option that you have in any option in milling, all the operation in milling will work in a mill turn machine, but not in a turning machine. Today, the issue, the subject was turning.
Okay, so thank you very much, and thank you everyone for joining us. Like I said, you will receive the link to the recorded webinar, and I hope you enjoyed it, and see you all next week. Bye.
Thank you guys. Bye-bye.